Okay, year 10. This video is about how to determine whether the ball will fall into the hoop. In the last video, we have done 4 parts in the mathematical modeling. Okay, so here, in this video, we're going to do the last part. Okay, this part. Alright, how could we do that? So the process is quite simple. First of all, you need to go to the data you collect from the Excel, and you want to get the coordinates of the hoop. So there are 2 coordinates. X means the horizontal distance, Y means the height, right? And you need to record that's coordinates. Alright, and you go to a new page and you just okay, so let's write it into a bigger okay, so let's hope x equals 3.88, y equals okay, so that's just for my the coordinates for my hoop. Okay, so in your video possibly it would be different. Alright, but you need to check. Okay, after you've got that, okay, remember what we have done last time. Okay, so in the last video we have found 2 modeling equations. One is in their vertex form, the other is in the general form. Okay, so let's first to get the equation of the vertex form. Okay, so here is the equation of the vertex form. Alright, so let's go to get the equation of vertex form. Okay, let's go back to our previous draft work. Okay, so that's our vertex form, right? So let me just copy and paste it. Okay, so first we're going to use this form to check whether the ball will fall into the hoop. Okay, so obviously we're not going to use you are not going to put both x and y into the equation because we're not sure whether the ball will pass through the hoop. Okay, so but you still need to check whether the ball will go to the hoop, right? So what you're going to do is to substitute that x into the equation and to get the y value for that x value, and you compare the y value you've got from the equation, and you compare that y value with the y value of the hoop. Okay, so let's put x equal to 3.88. Alright, and you have this one. And according to my calculation, right, you might use a calculator to do that. Okay, y would be like, when you correct to 2 decimal place, okay, it's 2.51 meter. Alright, so delta y would be, delta y means the difference between the y you've got for the ball and the y value of the hoop. Okay, so you use 2.51 to take away 2.70. Alright, okay, so and that will give you minus 0.19 meter. Okay, so what's the conclusion? That means according to this model, the ball will be 0.19 meter below the hoop. Okay, so that means the ball is not going to pass through the hoop. Okay, so you might just give the conclusion. Okay, so that's one of the using one of the equation, and we've got another general form. Okay. Okay, so here's the general form we've got in our last video. Alright, so okay, still I'm going to put the coordinates of hoop as a comparison. Okay, now I'm going to do the same process when x equal to 3.88, y equal to so that would be 2.45 meter. Okay, so right now you have another y, and this y is different to the y you've got from another model. Okay, so that means the two models are different. Okay, not just difference in form, but also difference in terms of the shape that it passes through, the points they passes through, right? And also you could anticipate that the delta y would be different in this case. So let's see. Okay, I should use approximation sign. So delta y would be okay, so this time it should be minus. Okay, so in this case is whether the conclusion is similar, but you just need to change that's 0.19 into 25. Okay, that's it. So that's basically how you determine whether the ball will fall into the hoop. Okay, right. And how about that's another equation which is in the Excel. All right. So let's go back to the Excel. Okay. So in the Excel, we still remember that we have So let's see. So this is the Excel, all right? And okay. So in the Excel, there's another equation right here. So now I'm going to show you how could you use Excel to check whether the points, whether the ball will pass it through the hoop. Okay. So first of all, you need to copy this form. Okay, and you open another sheet. Alright, so now in this sheet I also copy the hoop coordinates right here. I'm going to find the predicted height of the ball using Excel equation. So what's the Excel equation? Okay. Oh, not there yet. Sorry, it seems I haven't copied that one. I need to copy this. Should be copied now. Yeah, now it's there. Okay, let's go back. Okay, and okay, so okay, seems using Excel equation. Okay. So you see that now here is the predicted height using the Excel equation. But how could we get the value? You could use the Excel to help you to calculate. You don't need to use your calculator. Alright, okay, let's see how to do it. Okay, so first of all, you need to add a few things right here. So we understand that's 2 means power. You put power here, and also understand there should be a multiplication sign. Just make sure the Excel could recognize the formula. Okay, alright. Make it bigger. Okay, now I'm going to copy the formula, but this time I copy it without that's y. Okay, I'm going to this line. Right now it's x equals this formula, right? But I'm going to put the values of x into here, but I'm not going to put 3.88. Instead, I just press that. I just use mouse, click that 3.88. So the position of that 3.8 is column A, row 3. So you see A3. All right. And I move to here. I replace that x by A3 as well. Okay. And you just enter it, and it will automatically give you the value of y. So that will be the p data heights for the basketball using the Excel equation. Okay, and how can we find the difference in heights? Alright, so again, you don't need to type all the numbers. All you need to do is to type equals, and you want to use this number, so you don't need to input the number. You just click the number. Now it becomes C3, so that's the position of this number, and you take away. Okay, let's go back to a little bit here. So you need to take away the y value of the hoop, right? You just click that value. So now you see that C3 minus B3. Okay, C3 minus B3 means oh, sorry, I need to do that again. Sorry, go back here, let me do it again. Okay, now enter. So you got the value, which is minus 0.21. Okay, alright, so you could check anytime whether this equation is correct when you click that cell in the Excel. It will show you the equation right here. Okay, you enter it, it will just give you the value. So it automatically shows all the numbers you need. Alright, so actually you could do that for all the equations, even the equations including the ones in your algebraic work. Okay, I've done that here for my group of data. So you will see I'm using the Excel equation. I got difference minus 0.21. I use that vertex form. I got the equation 0.19, and the last one, if I use the general form, I got minus 0.25. So all are negative values. So that means all the equation, they quite consistently predict the ball will be below the basket, below the hoop. Alright, so let's go. So after you've done all this, you might be interested to go back to see whether that ball will go below, will go lower, below the hoop, right? Okay, so let's go back to the tracker. So when you watch the ball, you see it flies towards the hoop. Okay, but actually you could see this time the video stopped here, but you could anticipate actually if the ball follow the same path, so it most likely will come below the hoop. It can't actually pass through the hoop, right? So our prediction using mathematical model agree with what we see in the video, right? So that means the data is quite so what the work we've done should be right, okay? And how could we evaluate that three differences? Okay, so that would be the work we need to do in the solve and in the verify and evaluation part. Okay, that's for the final part for the solve part, for the mathematical modeling part. Okay, all right, so see you next video.